Hello all, today we're going to continue with the grade 12 syllabus, in particular defining conservative forces and giving an example. Now we're not talking about your politics, we don't care if you're conservative or a liberal, we're talking about work and forces involved with work. Now I hope one remembers that work is when you have a force moving an object across a displacement or a distance. So this force is pushing something or pulling something or acting on an object across a distance, and that is the work done. So depending on the type of force, we get conservative forces and non-conservative forces. So let's give you a definition of a conservative force. A force is conservative if the work done by this force in moving an object from one point to the other does not depend on the path taken by the object. So if you go from point A to point B, and it doesn't matter how you go from point A to point B, it is a conservative force. And the force is non-conservative if it does depend on the path taken. And in the process, here's another definition worth knowing. Mechanical energy is the sum of the potential energy and the kinetic energy. So mechanical energy is the sum of potential energy and kinetic energy. So that's what we're talking about today: conservative and non-conservative forces and mechanical energy. Now let's have a look at, for example, here. Here would be a pendulum. There might be point A, there might be point B. Now, if it doesn't matter how you get from point A to point B, let's imagine this is you moving, the force is moving, and eventually you go and you end up there, then that would be an example of a conservative force. But if it matters that you go the route that you travel in getting from point A to point B, then that would be a non-conservative force. Now, in just plain simple terms, the main forces we're going to be talking about are friction. That is a non-conservative force. It means that some of the energy is going to be lost depending on the route. So if you go over hill and dale to get from point A there to point B there, and the path you're taking, all along the path you're losing energy due to friction, and it ends up as heat, then that would be considered a non-conservative force because you're actually converting some of that energy into heat. So in grade 12 matric, what normally happens is we're talking about mechanical energy. You start here, let's say, there might be ground level. You start here, let's just draw a little, there's your ground level. Now you're starting there, and then you have a certain height above the ground. And gravity pulls and tension of the pendulum or string pulls, and the pendulum swings down. Now, frankly, it doesn't matter how it swings, but it ends up here. So there it has only potential energy, there it has only kinetic energy, and because it's on ground level, it's got no more potential energy. It's fallen by that height. And all that energy went into kinetic energy. Then, where do you think your pendulum will end up on the other side? Now we used to talk about this a lot in the old days, the law of conservation of energy. Energy cannot be created or destroyed, but may be converted from one form to the other. So it starts as potential energy, EP equals mgh, ends up as kinetic energy, a half mv squared, and then it's going to swing back up to there, and then the kinetic energy is going to be converted to potential, and then it swings back, and the potential gets converted to kinetic, then it swings back, and the kinetic gets converted to potential. And in the swinging, if you do this in a vacuum where there's no friction, and there's no friction at the point where the pendulum joins, then you're going to find this will swing forever. So no energy is lost. It's a conservative force because it's conserving the energy. And so unlike friction where your energy is being bled away and turning into heat, here our mechanical energy, remember mechanical energy is the sum of potential and kinetic. Here if we add potential, which is mgh, there's the h is always vertical height, it and there's no kinetic because it's stopped there. Then it comes down to ground level. Now there's no H because H is now naught. It's ground level. It's all kinetic, and then it gets and no potential. And yeah, it goes back to being all potential, no kinetic. Mechanical energy. That means if you add potential and kinetic at any point in the swing, the mechanical energy is conserved. So this force of gravity that is acting on it would be an example of your conservative force. And then, if we had a problem, let's just have a problem like this. You got a skier and he's going up and down, up and down, and up and down, and ends up. And let's suppose that our skier started at the first point and ended at point B. But the route he takes, if he's got a lot of friction, the longer the route, the more more mechanical energy is going to be lost, and due to friction. So it does depend on the route in this case. And that would mean that friction would be our example of a non-conservative force. So let's just go and have a look at the syllabus again. So know that when only conservative forces are present, mechanical energy is conserved. Well, we've seen that in the case of a pendulum. Know that when non-conservative forces are present, mechanical energy, the sum of kinetic and potential, is not conserved, but the total energy of the system is still conserved. So some of the mechanical energy got converted into heat due to friction. So that if you add all the energy, remember the law of conservation of energy says that all that energy cannot be created or destroyed, but can be changed from one form to the other. So here, mechanical energy has been lost when there's non-conservative forces such as friction, but the total energy of the system is still the same. Now it says solve conservation of energy problems with dissipative forces or frictional forces present using the equation work non-conservative equals the change of kinetic energy and the change of potential energy. So if you look at that carefully, what is the sum what is kinetic and potential energy? That is mechanical energy. So the change of mechanical energy is converted into work non-conservative, meaning heat, due to friction. So if you had a frictional force acting over a distance, force times displacement, and here our cos theta would be negative, be 180 degrees, because friction is always at 180 degrees to motion. Here, the amount of frictional force, the amount of work lost due to friction would be equal to the change of kinetic and potential energy. So it's not that hard to understand that some of our mechanical energy, those two, gets changed into heat energy or non-conservative work. Just know that formula. If they ask you a question to work out how much energy or work is lost due to friction, you can use this formula. Use the above relationship to show that in the absence of non-conservative forces, mechanical energy is conserved. So we already discussed that if you have no friction present, then mechanical energy is conserved.